Okay, so did you know that the difference between a B and an A star in Cambridge biology literally often comes down to just one single topic? It actually does. Section 3.2, the effective pH and buffer solutions on enzyme activity, is notoriously tricky. But listen, I'm going to show you exactly what examiners look for, straight from the principal examiner reports, and how to perfectly structure your answers to secure top band marks in this explainer. Let's dive in. So, what's the exact mistake that's costing you that top grade? Well, it's a super painful trap, honestly. You sit down in the exam hall, you see this giant complex data set on enzyme activity, and you just dive straight into solving it. But guess what? Right there, in that split second, you've already lost crucial marks before you even realize what the question is really asking. You're losing points not because you don't know the biology, but because you're missing the procedural framework that examiners are actively hunting for. And here is a pretty stark reality check for us. You can actually get a perfectly correct final calculation for a pH or buffer problem and still get absolutely 0 marks. 0. No way, right? But why? Because throwing down a correct answer without showing how you got there is kind of like arriving at a destination without a map. Examiners literally cannot give you the credit if they can't see the journey you took. If your logical steps aren't crystal clear, they simply will not award you the marks. Now, look at this quote straight from the principal examiner report. Candidates referencing cross-topic connections achieve significantly higher marks. This is a huge secret. You really can't treat topics like they just exist in a vacuum. You have got to connect buffers and pH changes to other biological systems you studied. You need to link them to precise definitions and clear causal relationships across the entire syllabus to lock in those top marks. So what are they actually testing? The core cognitive domains for 3.2 are knowledge and understanding, handling and evaluating information, experimental skills, precise definitions, and causal relationships. Basically, examiners aren't just testing your memory here. They are actively watching how you handle information. When you see a graph showing enzyme activity dropping at a specific pH, they want to see that you aren't just reciting facts. You're analyzing that specific data and actually evaluating the experimental design behind it. In just a minute, I'm going to reveal this hidden examiner clue that completely changes how you answer. But first, you absolutely need the procedural framework that makes that clue super obvious. Without this framework, you're essentially just blindly guessing what the examiner wants to read. All right, here's that standard procedural framework you need. Step 1, deconstruct the question. Step 2, extract relevant data. And please don't gloss over the graphs or tables. Step 3, select the analytical framework. Step 4, execute with clear notation. And Step 5, present with correct terminology. Think of this as your step-by-step action plan. This is exactly how you translate all that theoretical knowledge into an actionable, high-scoring exam strategy. Notice the massive difference here when you compare ordinary rote memorization of buffer theory with actual evidence-based reasoning and systematic analysis. Ordinary revision fails because just regurgitating facts simply won't get you through questions that demand evaluation, comparison of approaches, and justified conclusions. You really have to shift from a mindset of memorizing to a mindset of analyzing. It's a total game changer. Think of the method mark strategy as your ultimate grade insurance policy. Earning points for demonstrating the correct procedural process and clear working saves you, even if the final calculation is completely incorrect. Even if your math totally implodes under the pressure of the exam clock, showing your logical steps will literally save your score. It proves to the examiner that you know exactly what you're doing, even if you just hit the wrong button on your calculator. Let's walk through this progression of data interpretation. You always start by extracting data from tables and graphs, right? Then you move on to actually interpreting those relationships. Next, you calculate the relevant statistics, and finally, you draw evidence-based conclusions. This is exactly how practical problems involving pH and buffers are solved systematically. Okay, let's actually put this into practice. What does a failing answer actually look like compared to an A-star answer? I want you to challenge yourself here to spot the fatal errors in the flawed example we're about to look at before I reveal the examiner's correction. And boom, here is the exact difference. The flawed answer just throws out numbers with 0 units and gives a generic explanation that is totally disconnected from the context. But notice how the top band answer operates? It perfectly follows the ultimate sequence: concept, then evidence and data, then scientific reasoning, and finally precise examiner wording. That right there is the absolute gold standard for your responses. All right, so we know the right way to do it, but what about the pitfalls? Well, we dug through the principal examiner reports and we're going to break down the top 3 specific examiner warnings. These are the exact mistakes that consistently cost students their A star in Section 3.2, catching out even the most prepared students. Number 1, the classic trap, using the wrong terminology for the wrong context. You might know what an enzyme's active site is or how a buffer maintains pH, but if you apply that terminology loosely or to the wrong part of the experimental data, the examiner cannot give you the mark. Precision is literally everything here. Number 2 is a direct result of exam timing pressure. Honestly, there is nothing more painful than doing all the hard math perfectly, only to lose the mark because you forgot your units and terminology. You calculate a rate of enzyme activity, but you leave off the units or you use the wrong ones entirely. It's a completely avoidable loss of marks, but it happens over and over again. And number 3, providing generic answers. If the stimulus materials give you a specific case study, say about a particular enzyme in a specific buffer solution, your answer has to be perfectly tailored to that exact context. Rote-learned generic definitions that completely ignore the unique data provided are going to severely limit your score. To secure those absolute highest order marks, you need what we call a deconstruct, solve, evaluate cycle. This means evaluating the evidence quality by 1. Identifying limitations in the experiment, 2. Spotting any hidden assumptions made, 3. Finding alternative interpretations of the data, and 4. Determining exactly how all of that affects the final conclusions. Mastering this is the true hallmark of an A-star student. Now, how do we make all of this stick on exam day? We use the visual story encoding method. Connect pH changes directly to the 3D structural changes in the enzyme's active site. Visualize what buffer capacity actually looks like on a molecular level. Mentally map out that deconstruct, solve, evaluate cycle we just talked about. And always, always take a second to verify the reasonableness of your results. Actually picturing these concepts is a massive memory hack. So you've got the core principles, you've got the framework, you know the pitfalls, but here is the ultimate diagnostic cliffhanger. What if you misinterpret the very first word of the question? Seriously, even perfect method marks and flawless visual encoding won't save you if you don't actually understand the specific instruction the examiner is giving you. And that brings us to the hidden cause of lost marks. Command words. Words like explain, describe, calculate, evaluate. These single words dictate your entire mark band. If you describe when you are asked to explain, you lose. Command word awareness is the final, absolute, mandatory secret to a high-mark exam strategy. It's the bridge between knowing the biology and actually scoring the A-star. To make sure you have every single tool you need to build that bridge, definitely subscribe to our YouTube channel, Ace the Exams, at acexams_IGCSE to excel in your Cambridge examinations. Mastering the biology is step 1, but mastering the exam itself is step 2. Which means your mandatory next step is our next masterclass, Biology 9700 Command Words. You really can't afford to leave your command word strategy to chance. Click on the screen right now to bridge the gap and join the masterclass, where we'll reveal exactly how to translate every single examiner command into top band marks. Because ask yourself, are you really willing to let one misunderstood word dictate your final grade? Click through and I'll see you in the next explainer.